MGF1107 Chapter 10, Section 3. This deals with compound interest. The formula for compound interest is A, which is the amount, equals P, which is the principal, times, in parentheses, 1 plus R over N, which R is rate. N represents one of 5 values. If it says annually, it's a 1. If it's semi-annually, it's a 2. If it's quarterly, it's a 4. If it's monthly, it's a 12. If it's daily, it's 365. All right, and raised to the n times t power. So make sure you understand that n can only be one of these 5 values. Okay. Basically, these problems are just reading the problem and then substituting the numbers into the formula. So if we come to our first problem here, which is example 2, it says Kathy invested $3,000 in a savings account. There's our principal. With an interest rate of 1.8%. There's our R, 0.018, compounded monthly. So when it says compounded monthly, that tells us our N is 12. If Kathy makes no other deposits into this account, determine the amount in the savings account after 2 years. There's our time. So if we come over here, we substitute the numbers in. Here's our P, here's our R, here's our N times our T. 12 times 2 is 24. 0.018 divided by 12 is 0.0015 added to 1. If we then raise this to 24 and multiply by 3,000, we get $3,109.88. Notice that the compound interest formula is different than the simple interest formula. The simple interest formula calculates interest, which we then have to add to the principal to figure out the amount. This formula calculates the amount. But what we have to do is subtract the principal. So if we subtract 3,000 from this 3,109.88, we find out the interest that we made on this was $109.88. So different ways to get the same information. The next thing we have in here is called effective percentage yield or effective annual yield, which is called APY. The whole concept behind it is that if we compound the interest a certain amount of times during the year, then it's going to gain us more money. So like for instance, in this one right here, we're taking $1, which is our principal. It's at 4% interest, and we're doing it semi-annually. If we do this math, we get 1.0404, which means that this 0.0404 is 4.04% interest. If we were to do the same thing with simple interest, it would only be 4%. So even though we're at 4%, if we compound it, in this case semi-annually, our APY, effective percentage yield, is actually 4.04. So remember, compounding the interest more than once a year is going to gain you a certain amount of money. Now we go to present value, and present value really is the same formula as compound interest. The only thing we did was we took this 1 plus R divided by N to the NT power and divided it over. So this is the same formula. This is example 5 on page 388. And it says here that Will would like his daughter to attend college in 6 years when she finishes high school. Will would like to invest enough money in a certificate of deposit, CD, now to pay for his daughter's college expenses. If Will estimates that he will need $30,000 in 6 years, so he's estimating that he needs $30,000 to have his daughter go through college, how much should he invest now in a CD that has a rate of 2.5% compounded quarterly? So basically what this problem is doing is someone has done some research, figured out the money that they need and the time that they have to invest it. And so now what they want to do is find out how much money they need to invest to arrive at their goal. So what happens here is we take the $30,000 that he would like to have at the end of 6 years. We use the present value formula. Here is our N, which is compounded quarterly. Here's the amount of years, which is 6 years. Here's the interest rate, 0.025. If we do this math, we find out that in order for him to have $30,000 compounded quarterly, 4 times a year, in 6 years, at 2.5% interest, he needs to invest right now $25,833.30. So this is what this whole problem is about. This is about planning ahead. If he needs $30,000, then he needs to invest $25,833.30 now to achieve that $30,000 at the end of 6 years at a 4% interest quarterly rate. So that's what present value does. Present value allows you to predict how much money you will have with a certain rate in a certain time, compounded in a certain amount of times a year.